Hello and good morning, friends. Today I want to talk to you about something really easy, really simple, and I wanted to make a quick video about how do you calculate the size of a water tank. Now, in this particular example, we're going to discuss rectangular and cylindrical volumes. Most commonly, at least in our world, well in septic, it's going to be rectangular, but you do end up getting some other variety of shapes. So let's go ahead, get the piece of paper, and let's see what we're working with. So the formulas are really simple, right? So first off, if we're dealing with a rectangle or a square, our volume, which is the V, is equivalent to the length, the height, and the width. So we have our length, our height, and then the other dimension, which I'm not good at drawing, is going to be our width. So for perspective, an average septic tank in our area is 8 feet by 4 feet. It has 5 feet of total liquid volume in the tank. So if we multiply all that together, we're going to receive 160. Now, so we have our length, our height, and our width, and basically our volume is going to be 160. But that's not why you're here. You're here to figure out the water volume, and the magic number for that is going to be 7.5. So what we're going to do is we're going to multiply by 7.5, and we're going to see what that number gives us. After all of that, now our total liquid volume for this formula is going to be 1,200 gallons of liquid. Now, this is not accounting for the thickness of the walls, so when it comes to septic systems, because we're at 1,200, that means that the next logical tank size has to be 1,000 gallons. Septic tanks in our area will come in 500, 750, 1,000, 1,250, 1,500, and 2,000. Because our volume is 1,200, we know it can't be a 1,250 tank because that number is too small. So the next size down has to be a 1,000-gallon tank. So this is a really quick and easy formula that you can use to calculate the volume of your tank. But let's go ahead and talk a little bit about water in a cylinder. Maybe you're also trying to do a Drywell calculation. So the first thing we need to figure out is the height and the radius. So basically what we need to do is we need to figure out how big our pit is. So we're going to use Drywells for sake of argument, just because we're sticking on the septic theme. In our area, most Drywells will have 10 feet of total height, 8 feet of diameter, right? And pi is going to be 3.14. So if our diameter is 8, our r squared is going to be 16. So we can see if we have 10 feet high, the radius squared, which is 16, times 3.14, we're going to end up doing this volume real quick. So with that, that means that our total volume is going to be 502.4. Now remember, that does not tell us how many gallons are in this pit. So the next step that we need to do is multiply by 7.5, which is going to give us 3,768 gallons of total capacity. So when you're calculating this, it's very simple, but again, we're not accounting for wall thickness and we're rounding up to the nearest hole in feet. So our number is going to be a little bit inflated compared to what the actual number is. I hope that this helped, but remember, this is our tank size. This is going to be how we calculate the volume of the tank. If we're trying to calculate the volume of our Drywell, this is how we're going to do that, right? So this is the most common setup that we'll see in a house, in, let's just say Carroll County, 1974. This is the size of the tank, so usually it'll be about a 1,000-gallon tank. This will be the size of the pit. So you'll have a 1,000-gallon tank with roughly a 3,700-gallon absorption area. I hope that this makes sense. I'm not the greatest of math people, but this is something that you're going to end up using if you're trying to calculate the volume of a septic system. If you found this informative or useful, make sure you hit that like button and subscribe. I look forward to talking to you guys tomorrow.